Conclusions. Cybersecurity is a real challenge, and the future of the Internet partially depends on how that challenge is met. For a long time it has been clear that the cybersecurity response to the fast-evolving threat needs to be much smarter than has been the case. The alternative is bound to lead to the situation predicted by Jonathan Zittrain: if the problems associated with the Internet are not addressed, a set of blunt solutions will likely be applied to solve problems at the expense of much of what we love about today's information ecosystem. This lecture focused on anomaly-based intrusion detection. But the role of AI in cybersecurity should not be seen as limited to that. Some cybersecurity problems needs urgent attention, for example the BGP, Border Gateway Protocol. In that case, as was the case with the DNS system, the origin of the problem has to do with authentication. It seems that there is little that a human expert can do, let alone an AI system, without an authentication protocol. Today that means a cumbersome system of keys, which slows down everything and introduces new failure modes. Furthermore, as we saw recently with MD5, encryption protocols get eventually broken. BGP does not have a system of authentication based on keys. It has no authentication system at all. It is vulnerable to any rogue routers. That is not sustainable. Eventually BGP may also use an authentication system based on keys, with the same negative consequences. A very nice scenario would be that AI could offer other ways toward authentication, which is one of the major basically unsolved problems in cybersecurity. There is an imperative to put far more artificial intelligence in cybersecurity. The question is how best to do it. Artificial intelligence is a vast and advanced field, still relatively immature and definitely not optimized for cybersecurity. Specific work will be needed in artificial intelligence to facilitate its application to cybersecurity. Progress on that front will go faster if the possibility of applying AI techniques in cybersecurity inspires more interest to the AI community. Cybersecurity could turn out a very good field of application for AI. It has the computer-to-computer interaction dimension and some of the problem-solving culture. Newell and Simon 1972, developed an AI may find a natural area of application there. One obstacle to the development of the interface between the two communities, security and AI, is the way security world operates. In cybersecurity, there is no real repository of knowledge. The knowledge exists, there is a lot of it, but it is scattered and not codified. Instead of looking at AI to try and find some tools which could be applied directly to cybersecurity, security people should have a harder look at their field, to make it more easily penetrable to outsiders, like AI people. As long as the approach to security is organized around the specific of attacks and the defense consists in looking for ways to prevent them, through some tweaking of existing protocols or functionalities, this will not happen soon. A possibility would be to be able to develop some sense of situational awareness which could be communicated or inoculated to the AI-based tools. AI systems and human beings differ in significant ways. The implications of those differences will be clearer when operational AI-based tools become far more common in cybersecurity. Although the limit of the possible in AI is really ill-defined, it exists.